All right, good morning, everybody, and welcome to today's episode of This is Automation Live. I'm your host, Corey Dallas, and we're happy to have you here. If you haven't already, go ahead and take a second and just subscribe to the channel. That's really helpful for us to know that we're putting out good stuff that you guys are interested in. So make sure you subscribe. The next couple live streams are already up, so you can go set notifications for those so you get a reminder on your phone when those go live, and you can make sure to jump in and tune in. If you want to get in touch with us or just let me know something that I did right or wrong, or want to suggest a topic, you can do that by leaving a comment below. You can reach out to me on LinkedIn, or you can send me a message through YouTube. So plenty of ways to get in touch with myself and anybody else that we have on the show. So today we're going to be talking about coding best practices. This is an interesting topic. It's there's certainly some debate about some of the things that we're going to be talking about today, and a lot of this is preference. But I think the most important thing is that you're using some guidelines to code against, so that you have good readability in your code, that your code is scalable, and inevitably when someone else comes in to make a change to your code or to look at your code, that it's readable and easy for them to understand exactly what's going on. So that's a really important part of good code, is not just that it functions, but also that it's readable so that you can scale it, make changes to it, so on and so forth. So we're going to be talking about some things like naming conventions, a few little best practice, tips and tricks that you can use in Automation Studio. We'll show that in some of the slides first, and then we'll hop into Automation Studio to take a look at a few of those little tips and tricks. So hopefully this is valuable for all of you out there, and we'll get started in just a second. But before that, I wanted to tease out the next couple episodes. So we have one coming up on Tuesday on managing intellectual property. Very, very important topic, especially as more and more intellectual property is tied up in software instead of kind of the traditional like hardware and mechanics. It's really important to make sure that you have the right mechanisms in place to protect, what's important, your intellectual property. So we'll talk through some of the software and hardware tools in the B&R ecosystem for how to do that. Then coming up that Thursday, next Thursday, we're going to be talking about version control and specifically Git. So there's many, again, different version control systems out there. A lot of it is preference, but we use Git a lot on projects in the B&R world. So we're going to talk through that. It's a pretty popular one. We'll talk about kind of an introduction to Git if you're not familiar with Git, and then how to use it with Automation Studio. And Automation Studio is very nice in that kind of in the back end of everything, it's all kind of text-based files. So it's really easy to manage those in a version control system. So we'll talk through more of that in detail. This is normally the part where I introduce my guest, but today it's just me. So if you don't like me, well, too bad. We don't have anybody else to help me out today. So it's just going to be me walking you through this stuff. But hopefully I can still bring some value to everybody out there. So let's go ahead and jump into it. When we talk about coding practices, one of the first things that we need to talk about is naming conventions. It really impacts the readability of your code, as well as how easy it is to troubleshoot, how easy it is to add things on. So this one's kind of dead simple and probably pretty obvious to everybody out there, but the first thing is using descriptive names. So any identifiers that you have in your software, you want to use descriptive names, whether that's a variable like what we're showing here. When you put pressure 1, that may mean something to you when you program it, but 6 months later when you come back, you may have trouble. Which pressure was pressure 1? So try to use something descriptive where possible. But also be cognizant of how long the identifier names are getting. So I would say something like this pressure lift cylinder that we're showing on the screen is maybe on the limits of how long an identifier should be. So just be cognizant of that. You can use some shorthand, maybe instead of pressure, just put press, PRESS. But you just want to make sure that it's clear and concise. Pretty easy, but we have to say it because you'd be surprised how many Automation Studio projects are full of pressure 1, pressure 2, pressure 3, pressure 4, and then it becomes quite a challenge to diagnose any issues. Okay, so when we talk about naming, there's a few different conventions for how you should case your variable names or other names. So there's three really popular types. The first one is underscore case. It's pretty self-explanatory. Anytime you have compound words, for example, you would put an underscore between them. So in our example of like pressure high or something, it wouldn't be pressure and high together. You'd put pressure underscore high. Camel case is somewhat similar. It's named because of the humps on a camel. So with camel case, you're typically starting the first letter lowercase, and then any additional words you would start with a capital letter. So that improves the readability. And then lastly, we have Pascal case, which is also known as upper camel case. It's the exact same as camel case, but the first letter is capitalized. So in the kind of standard B&R coding guidelines, there's a training manual. If you've gone through B&R training, you probably have that. And if you need a copy of that, just reach out to your local B&R representative. But there's actually kind of a mix of these in that guideline. So that's what we're going to use kind of as a reference is that B&R documentation. There's also some information about this in the B&R help, but just what we're talking about when we say underscore case, camel case, and upper camel case or Pascal case. That's what those are. Okay, so now we'll kind of walk through some of the different naming conventions for the different things inside of Automation Studio. So the first one of those is data types. So we won't talk too much about what each of these things is. So if you don't know what data types is, that's okay. Don't worry too much about that. And we can maybe cover that in another episode. But for those of you that use data types, and I imagine that many Automation Studio programmers out there are, when you're using a data type, it is always very helpful to append underscore type. This is kind of the recommendation that we do. So the name of your type would be in a Pascal case in the examples that we're seeing here on the screen. So recipe or machine params, and that would be followed with underscore type. This makes it really easy to identify what is a data type, and is again just a readability thing to make sure that there's no confusion. If we were just calling this recipe, it may be a little confusing, especially if someone's used to having the type called out. So it's important to note that a lot of these naming conventions are for the sake of readability. This isn't like a requirement for the compiler to make this recipe a type. Just by assigning it under the type definition file, it's going to get compiled correctly. But yeah, for readability and scalability of the code, that's why we do a lot of these things. Okay, for constants, we recommend all caps and underscore case. So again, this helps really clearly when you're reading through code, okay, this is all caps, so this is a constant. And then we use underscore case when you're using all caps because otherwise it's very unreadable. I'm sure you can imagine heating time out. If you smush that all together, it becomes very hard to read. So again, recommend the underscore case to kind of break that out. But anytime you're defining constants, using all caps is helpful. All right, local variables. Again, a matter of preference, but what we kind of recommend is to use upper camel case here. Use descriptive names. So again, when we say upper camel case, in this case, we have machine step. So 2 words, machine and step, instead of cramming those together with no, delimiter for what the next word is, we're just using a capital letter to indicate that. So, and maybe just a quick note here, your variables can contain letters and numbers, but they have to start with a letter. So you can't start a variable with a number. So just keep that in mind as well when you're putting your naming conventions together. All right, global variables recommend a prefix of a lowercase g. So you would use the same camel case descriptive variable name for the kind of main part of the variable. So in this case, like heater on or actual command. But then you would just put a prefix of a lowercase g. really easy way to know that, okay, this is a global variable that I'm working with. Anytime you want to call a global variable, it's really easy. You type G, hit your control space to bring up that autocomplete, and you've got all your global variables all in one place. There's never any confusion when you're writing your code as to what's a global variable, what's local, what's package local, et cetera, et cetera. So very, very clear notation and really helpful when you're writing code. Okay, a similar one, when we're using pointers, it's helpful to put a prefix of P to that, so that you know that this is a pointer and not a variable. So if we were to just call this actual recipe, it may not be clear that this is actually a pointer, in this case, to reference to the recipe type. It may be confusing if you were to just call this actual recipe. It's a pointer, but again, reading back through the code, when you go back and look at these things, it's going to be confusing. So a prefix of P on your pointers is best practice. All right, hardware variables. So these are variables that you would, tie directly to your inputs or outputs, whether those are digital or analog. So in those cases, we recommend this, again, prefix to indicate what those are. So if it's a digital input, DI, digital output, DO, analog input, AI, analog output, AO, and a temperature input, AT. So pretty simple, pretty straightforward. But again, just a really nice way to know that this is a hardware related variable and not an internal variable. Function block instances. This is one that I see a lot of people where they'll remove the function block name from a function block, and it can get really confusing when you're troubleshooting. So my best recommendation here is put the function block as the first part of your function block instance with an underscore, and then camel case of a description. So if we've got a valve on timer, for example, and we're using the ton function block, ton underscore valve on timer, that helps me know, okay, this is the function block ton. So that automatically kind of registers some stuff in my head. I know what the inputs and outputs are. I know kind of what to expect. And then I also have valve on timer, so I know what this timer does. So those are kind of the two parts that are important. You want to be descriptive, but you also want to be clear that this is a function block and what function block it is. Again, if I were to just call this valve on timer, it's really confusing when you're looking back through your code, and it's not clear that valve on timer is a function. Maybe it looks like a data type instead of a function. So really important to leave that function block name in there. It's super, super helpful for diagnostics. Okay, another one that's maybe underused, I would say, is enumerators. So enumerators, and we talked about this last episode a little bit. So we use these a lot in like a state machine. So a state machine where we have these different defined states for our machine, and then some transitions between them that are defined. So for example, we may start in an initialization state, and then once we're initialized, move to a home state. And then, in this case, what we're showing here, some valve cycle state, then a run, then a stop, and then, maybe if something goes wrong, we'll go to our error state. One really clean way to handle that is to use enumerations, which are basically just a way to, instead of showing state 0, 1, 2, 3, an enumeration takes that and assigns a readable text to it. So in this case, I've defined my enumerator as state, and then the different enumerations are state init, state home, state valve cycle. So the best practice there is to use the name of the enumeration, in this case state, as the first part of any element, an underscore, and then the name of that specific element. So in this case, init or home. So that helps me know, okay, this is part of the state enumeration, just quickly at a glance when I'm reading through my code, and then a descriptor of exactly what it is. So that again helps. Maybe an underused part of Automation Studio. I'm sure some of you guys out there are using this, but definitely something to look at for your state machines or anywhere you're using zeros, 1, 2, and it'd be easier, in your case switch statements, it'd be easier to have something text readable. All right, I think we're out of naming conventions, which is maybe the least fun part of this, but really important to cover. So when we talk about best practices, naming conventions is maybe the first one that comes to mind, and then code formatting is another one. Again, these are all somewhat preferential and are really designed to make it easy to read and to develop your code. So something that is hard to do up front, but really, really worth it when you're going back to look at code that you wrote, again, 6 months, 12 months ago, is a descriptive header for each file. So what information you put in here is kind of up to you. It's recommended to put, the company, the author, the date, a description of what the file does, and maybe in some cases a history. So the nice thing about header files is instead of having to type all these asterisks out yourself to comment this out at the top of a file, there's actually something you can use called snippets. So snippets are really nice to take code that you're going to use often, put it into these snippets, and then you can actually use some hotkeys to drop those in. So the way to get to that, and I'll show you that in just one second, but the way to get that is to use tools. So when you're in Automation Studio, if you click on tools, you'll get this drop down on the left, and there's something called the Code Snippet Manager, in the bottom 25%. So if you click on that, the window that's on the right-hand side here will actually open up, which is our Code Snippet Manager. And in there's if statements, loops, those kind of things that you can use, which are really nice. And you can define these for each language. Right now we're looking at the C snippets, but we'll look at structured text in just a second. But the other one that you'll see in there is actually file header. So when we click on the file header, you'll notice that it's got that already defined for me, and I can add anything that I want to this, so that anytime I create a new file, I can just insert this file header, and there's going to be consistency, and also it's going to be much, much easier than doing this manually. So let's take a quick break from the slides and actually jump in to see what that looks like. Real quick, this is what I'm talking about when I say quickly adding that. For those of you familiar with the control space hotkey, that's the autocomplete. So if I were to type file, control space, file header pops up, I hit enter, and it's going to auto-populate that file header. So let's take a quick look at that inside of Automation Studio, and we'll demo that real quick. So you can see I've already got my header right here at the top of the code. So in this case, I've got the company name, the author, my username, when it was created, and so you can see that I did this at 10 o'clock in a description. So I didn't put a very good description, but just for the sake of examples. So what I will do here is show you where the manager is. So again, in Tools, Code Snippet Manager, I'll scroll down to those structured text snippets, and we'll click File Header. So if you're opening this in your Automation Studio, you may notice that it's just this section that I've highlighted. So I've actually added this description just to kind of show you what you could do to make this better for you. And you can actually define some of these like variables, maybe we can call them these literals, using this table here. So I've added this description ID, a default value, and the tooltip that's going to show up when I insert it. And we'll show you what that looks like. And if you wanted to insert one of these into your snippet, use this $ notation. Okay, great. And now we will type file into the top of our file here. I will push Control Space. I will push Control Space. Let's try that again. Okay, there we go. Control Space, and I will add the file header. Okay, so you can see when I added the file header, it puts exactly what we were just looking at in the Code Snippet Manager, which is great. So it's got the company it pulled in automatically, my name, the current date and time, and my description. And you can see that I've got a nice little area where I can type in my description. So this is really nice to make sure that this isn't a lot of work to implement, and that you can kind of quickly do this at the top of every file. So I'd recommend setting up that snippet, and then your code will look much nicer and be much more scalable going forward. Okay, let's hop back. Good. All right. So again, that's what we end up with. Nice little snippet. You can add as much information in there as you want and really customize it for your application. Good. So code formatting is super, super important. When we talk about code formatting, a lot of the times we're talking about spacing and we're talking about tabbing and we're talking about visual alignment. So what we're looking at on the screen here is an example of visual alignment. Now, let's say I've got some chunk of values that I'm assigning. So in this case, I'm assigning my hardware variable to some internal variable. So I've got left temperature. I want to feed my temperature module, left temperature to that, so on and so forth. This is fine, but a way to make this much more readable and really kind of show that these are all grouped together. This is kind of similar activities happening here. So I want to have some visual representation that these belong together. So the way you can do that is actually to use tabs here to line up, in this case in structured text, my colon equal sign, to line those up for a block of text or block of code that kind of belongs together. So it makes it much easier to read. So now I know just from a quick glance, okay, this stuff goes together, and I know very easily what's going on here. It makes it much easier to read since all of my values are aligned. So we can quickly look at what that looks like in Automation Studio. Okay, good. So here you can see where I have my no alignment. So when I've got no alignment, it's basically I have consistent spacing. So one space between my equal sign and the variable on the left there. But what I can do to kind of get myself to this nice state here is just use the tabs. So I'll tab over for all of these, and then boom, look at that. It looks so much better. It's easier to read. These things are visually grouped together. It's a really nice tool. So really simple, just tab over, make your spacing consistent, and you're good to go. Excellent. All right. So another thing that's spacing related is indentation. Now, the great thing is Automation Studio does this for you automatically for the most part, but it is not uncommon as you are developing for things to kind of get mixed up. So it's probably not going to be as bad as what you see on the left-hand side with no indentation at all, but you may end up with some, if statements that are out of line, which makes your code really, really confusing to read. So on the right-hand side, it's very easy to see, when I have these nested, if statements and nested for loops, it's easy to see which code belongs with which statement. But when they're over here on the left-hand side, it becomes much more difficult, especially if there's a lot of code in these if statements and for loops. So when we're looking at something like that, there's actually another nice tool in Automation Studio called Format Selection. If you basically select some text in your editor and hit this Format Selection button, it will actually take that unformatted, untabbed selection and automatically format it for you. So that's a really, really nice tool. Again, if things get a little wonky in your code, you can use that to quickly fix it. So I'll show you that real quick. Okay, so here we've got my example with nice clean spacing. Everything looks great. And now here I've got my mess with no indentation. What happened, I don't know. But because Automation Studio is handy, we can highlight our text. So you can see here I've just highlighted from the top of my if statement to the bottom of this if statement. And up here in this toolbar, I'll select Format Selection. In mine, it's the one on the farthest right. I'll press that, and there you go. Automatically has realigned all of my statements and loops and automatically indexed and tabbed everything out. And it's much, much more readable in this structure now. Okay, so that's a nice tool. If you didn't know that was there, I'm so sorry. If you've been manually tabbing things over, it can be a real pain, but this format selection tool is really great, especially if something gets inadvertently messed up while you're developing. All right. So comments are important. One of those things that you probably try to do a really good job of at the beginning of a project, and then they slowly get worse and worse. But it's really important to make sure you're keeping up with your comments. There's maybe two main things I would say to use your comments for. One is to describe the purpose of a section of code, whether that's an entire chunk of if statements, or if it's just a single line that needs to be explained. Very helpful, again, as you're going back and looking through to understand what's doing what in the code. And this is also helpful if you're going to have someone else come in and look at your code. It's much easier to have those human readable comments instead of having to try to figure out what you were doing with this if statement and that for loop. Much easier. The other thing that you can use it for is to mark errors. If you know there's a problem somewhere, you can either just comment out that section and just put a note that there's something needs to be fixed here, or you can mark future work. So you can see in my Automation Studio, I've been putting these to-dos. I'm not sure if you've noticed that, but every time we've come in here, I've had a to-do. So this is something that you can use during development. Once you are ready to deploy your code, you probably don't want to have any of these in here or anything that says this doesn't work, comment it out. You probably want to clean that up. But for the purposes of development, having these comments in here, these kind of marker comments to show you, hey, there's something that I need to do here. In this case, I want to show you guys variable mapping. We'll do that in a second. But you can see I've got some pretty lightweight comments here just to help keep myself focused on exactly what we're doing. But you may want to put a little bit more detail in here. Again, if your code is so complicated that you need a paragraph to explain what's happening, you might want to consider restructuring it. But in general, a concise statement about what's going on in this chunk of code is going to be enough. The other thing you kind of want to avoid is just things that are going to be obvious to any programmer. So you wouldn't want to say, explain how an if statement works. If it's very obvious what's happening, there's really no need to comment it. And at that point, you're over commenting, and you're going to start clogging up your code. So we want to avoid that. But you definitely want to make sure you're using comments. Okay, great. So out of spacing, now I've got a couple quick tips. This is an interesting one that comes up often when we're talking about best practices is anytime you're looping through arrays, for example, or you need to get the size of an array, you want to avoid hard coding that. So let's say I wanted to loop through an array of 10 pressure values and do something with them. Right now, that may be 10 pressure values. And so it may be fine to say, for I equals 0 to 10, do this and loop through those. But the problem is what happens when you add an additional pressure sensor. So now your array has gone from 10 to 11. So you're going to have to make sure you go back and anywhere you've used that array size, make that change as well, or you're going to run into issues. And it may not get caught by the compiler, especially in the instance where you're looping through less than the size of the array. It'll just do that, and you'll probably get bad data back because you're expecting it to go through the whole array, but it's not. So to make that really dynamic, what you can do is use this size of function instead of hard coding the size of your array. So anytime you've got an array and you want to loop through it, you're going to want to use this size of. So what size of does, you can see here the first line, size of array. So let's just say I have this array. It will return the size of that array in bytes. So the actual memory that array is taking up, it'll tell you that. If it's 8 bytes or 16 bytes, whatever it is, it'll tell you exactly that. If we are to do the same function though, on a single element of the array. So in this notation, we've got array square bracket 0 square bracket. So the 0th element of that array, so the first element of that array, that will give us the size in memory of one element. So again, size of array will give us the memory that the entire array is taking up, and size of that single element will give us just the memory that element is taking up. And hopefully you can see where I'm going with this. If we know how much one element takes up, we know how much the whole array takes up, we can just divide those two values, and then we know, okay, this is 8 elements to fill up this much space. So that's exactly what we do. So you would take the size of array, divide that by the size of a single element in that array. Usually want to use 0 because an array is always going to have that 0 element, regardless of how big or small it is, and that'll return the number of elements. So from there, we can just drop that into our for loop, for example, and we've got a really scalable function. We don't have to worry about anytime we change the size of our array, this is going to already be done for us. So I've already shown that in the slide there, but we can jump over and just look at that in this structured text notation because we're not showing structured text in the slide there. So again, here I've got a for statement. Let's say I'm using this this integer I is equal to 0, 2, and then I want to loop through my entire array. So again, instead of putting the size of my array, which in this case would be 10, because I've got an array from 0 to 9 view sense, I'll take the size of that array, which will give me the memory size of the entire array, and then the size of a single element, and divide those two. And so now this expression will return 9 or 10. Yeah. So in this case, it would return 10. And if I'm going from 0 to that number, I'd probably want to do a -1. So that's something else you have to be careful about when you're doing that size of, is exactly how that works out depending on what you're counting from, what you're counting to, and how your array's structured. But regardless, that gives you a really nice scalable way to implement a loop through your array or any other use case for using the size of your array. All right, hardware related variables. This is something that can be really helpful, is to create a data type for your hardware related variables. And when we say hardware related variables, generally we're talking about IO or something like that. So the variables you want to tie to your IO, whether that's the actual output or input or the module status of that module. It helps to define these in one location, because then you can actually turn off the entire set of hardware variables if you need to simplify your troubleshooting. And also, it's much more readable if you have an IO structure, for example, like what we're showing here. I've got a global IO structure with an output structure that has my hardware module that has that specific output DO01. When I do it that way, I don't have kind of a mess of variables. For those of you familiar, that the B&R hardware modules have a lot of diagnostics data assigned to them. So if you're pulling those into different places, it can be kind of confusing. But when you're using a kind of a standard structure like this for your project, all the hardware modules in one place, you can loop all of those module OK values. You can get the serial number, and you have kind of global access to that throughout your software. So this is a nice implementation of how you can simplify that. So again, a little bit of preference there, but let's take a quick look. Here I've got an example of an IO structure. This is the one we were just looking at on the screen. So I'll show you, the benefit of that. So if I use my GIO, I don't have anything under input, so that would be silly. But output, then I can see I've got two different DO modules. Let's say I'll use group 2 in this case, since we already did group 1. And now I've got, the output values. I've got my module OK, I've got my module ID, my serial number, all in one place. So I always know where to find all of this stuff. So this can be really, really helpful when you're programming, so you know exactly where everything is at any given time. Okay? So again, just a helpful tip. Get all your hardware related variables in one place, put them in a structure if you can, and that's going to help you with usability and ease of use of your code. Good. All right, something that came up in the last episode that we did about organization in Automation Studio is communicating between tasks. This is something that we need to do a lot. And there's two main ways to do it. One is to use global variables. So pretty much just like what we saw just now. Maybe something that I want to communicate all the time is my hardware, right? My hardware output. So maybe I want to communicate that across different tasks. I want to be able to access my outputs from different areas, for example. So using a global variable is one way to do that. So this IO data type, this GIO of the data type IO is accessible globally. So I can use this in any task, whether it's the one we were just in or a different one. That's one way to communicate between tasks. The other way is to actually use a feature of Automation Studio called variable mapping. So variable mapping is, again, maybe one of those underused features, and you have to be a little careful when you use it, but it can be really powerful for times where you need to send data across different tasks, and you don't, for some design reason, want to make those variables global. So the maybe easiest way to look at that is to just jump into Automation Studio real quick. So you can see I've set up the example that we had on the screen was this initialize. So let's say here I've got this sequencer task, and I have an initialize all for my sequencer. So here in the init, I'm just setting it to false. Then I also have two other tasks. So on the logical view here, I've got my motor control task and my valve control task. And when I issue this initialize all command from the sequencer, I want to send that value to a local initialize command within both valve control and motor control. So if we just look at those real quick, so in motor control, I have initialize motor. Again, just a very simple example. And in valve control, I have initialize valve. So these are just getting set to false in the initialize routine. But how do I actually connect those two? So that's where we use variable mapping. So variable mapping is found inside the configuration view here. So we'll click on configuration view, and you can see I've already got the variable map here. But if you want to add one, you just expand the hardware folder, go into your toolbox, and pull in this .vvm file, the variable mapping file. Okay, I've already done that for this example, so it's already open. So when you're doing this, you're defining a source variable and a destination variable. So in this case, the source variable is going to be initialize all. So I want to take whatever initialize all is and send that to initialize motor and initialize valve. So to do that, I've just added using this add mapping, and then I selected my variable. So I can come in here, select initialize all, and then I select, again, similarly, my destination. I won't do this because it's already assigned, but I think you kind of get the idea there. I would just pick whichever variable I wanted this to land in. And from there, I've now got my variable mapping set up. Okay, so initialize all will go to initialize motor, and initialize all will go to initialize valve. Okay, so in that case, if we have, let's say, our valve control watch window open and our sequencer watch window open, I've now got my initialize all variable pulled in and my initialize valve variable pulled in. So hopefully, if I've done this right, if I set this to true, yep, there we go. We should see our initialize valve go true. Now, the important thing is I can't reset this, okay? So whatever is in initialize all is going to get forced into here, okay? But this can be a really nice tool for when you want to communicate across tasks but don't want to use a global variable, okay? Good. All right. So from here, that's pretty much what I wanted to cover today. So we looked at some of the different naming conventions that we have. Again, some preferential, but it's good to just maybe build up, if your organization doesn't already have one, a set of coding guidelines. If you want to use the ones that we presented here today, awesome, great. We're confident that those will work. But maybe there's some preferential reasons that you want to do something else. That's fine as well. The important thing is that you're just remaining consistent and that you are doing something, right? So naming conventions is one. The spacing was another important one that we talked about. We looked at some of the tools in Automation Studio to help you out with some of the best practices, whether that's the Snippet Manager or maybe the format tool. So all those things can really help you to build out really nice formatted code to make sure that your next project hopefully is really clean, really well implemented, and then you won't have that head-banging feeling when you go back to edit it in 6 months. You'll know exactly what's going on because you've commented it out. It's got nice standard naming conventions. It's formatted well, so on and so forth. So Hopefully this was helpful for those of you out there. I know a lot of this is going to have been review, so sorry if some of it was painful for those of you out there that are advanced users. But hopefully this is a good refresher for those of you that are more advanced in Automation Studio, and for those of you that are new, hopefully this helps you to establish a good base understanding of some best practices, and you can take this and develop it even further and make sure that your code is going to be really great, functional, and also easy to read and easy to use. So quickly, I will just talk through these next episodes again, just to tease them. We've got Managing Intellectual Property coming up next, Tuesday, April 21st at 9 a.m. Set the reminder. That's going to be a good one. Again, especially OEM machine builders, I would recommend tuning into this one. And then after that, we have Git with Automation Studio. So if you're not familiar with Git, we'll talk through that. If you're not familiar with Automation Studio, you might want to go watch Automation Studio 101. But we are going to talk about how to use version control in Automation Studio. I've got a good guest lined up for this one, and that'll be Thursday, April 23rd, again at 9 a.m. So make sure you set up reminders for that when you subscribe to the channel. And again, I hope this was helpful for you. Thank you, everybody, for tuning in. And I see a couple comments there. I'll try to get to those shortly after. But thank you again for joining, and we will see you next time on This is Automation.